Okay, so with these, now that we know how to solve higher degree polynomials like third degree, especially volume applications are accessible to us because we multiply three sides together to get volume. So one of the main applications is find the dimensions given the volume, and those are the directions for this problem. So I'll try to draw a three-dimensional shape, and the question we're answering is, what should outer dimensions of the picture I'm going to attempt to draw in a second. What should outer dimensions be to hold 36 cubic feet? So you write that as feet cubed of water. I'm sure you'll do something similar in science class, or you'll find the volume of an irregular shape by displacing it with putting it in water and displacing it. But okay, so let's see here. Now this is why I don't teach geometry, because I don't like drawing these things. So you will probably do this better in your notes than me, which is just great. It's coming. Okay. Well. Oh wait. There. Okay. And then hold the applause. So then, but wait, it's open, so this is cut out. Oh. And so the dimensions, so this is part of the problem, is each of the walls, it's like a planter box. Each of the walls is like 1 foot thick. 1 foot thick walls. So I can, like, this distance from here to here is one. All the way around. All the walls are 1 foot thick. Let me zoom in. Okay. So the hardest part is always writing the equation, but the dimensions, the dimensions are also given. So you're told that the length is twice the width, so that would be 2x and x, and you're told the height is the same as the width. So basically this is like a square here, this is twice as long. Okay, so if we want to multiply, what should the outer dimensions be to hold 36 feet cubed of water? We need to find the area of that part inside. So if the walls are 1 inch thick, that would be this, and then we can try to visualize it. 2x, so this length is 2x. Remember the picture frame where we had to subtract part of it? So do you see that this length inside would be 2x minus 2? Right? This inside would be, this whole thing is 2x. All the walls all the way around are 1 foot thick, so you have to subtract. This is 1, and this is 1. So you have to subtract 2 from each side. And then the length this way is, what do you think? Yes, x minus 2. And what about the height? And remember, there's a bottom that's 1 foot thick as well. What would the bottom, what would this height be? X minus, would it be minus 2 or minus 1? It's open at the top. And the bottom is 1 foot thick. Minus 1, that's right. And that is all equal to 36. That is our equation for a box, and we want just the volume of the water inside. It's just try and picture, I wish I had something like it in there, but all the way around, it's thick. Or you're in ceramics class and you're making something, and you have an inch of clay all the way around the outside. So the volume of the water inside, you would multiply those three together. So now we just need to solve this. So what you do is you you have to multiply it out and get it equal to 0. Remember, to use the zero product property, we need it equal to 0. So we just multiply it out and get it equal to 0. So you would start by multiplying the first two together, and then you would multiply it by the last. That's why we practice this skill. So let's multiply this out and then this out. So you get 2x squared. I'm going to go a little bit faster. Minus 4x, and then you distribute minus 2 plus 4. So we got that times x minus 1 equals 36. You can always rewatch this. And then I'm going to distribute the x to everything. So we get 2x cubed minus 4x squared minus 2x squared plus 4x, and I'll distribute the negative 1, minus 2x squared plus 4x plus 2x minus 4 equals 36. Yep, nice and ugly. It's just, so there were 4 terms here and 2 terms here, so if you distribute, you'd have 8 terms. So combining these, we should get 2x cubed. If we combine the squareds, minus 8x squared plus 10x minus 40 equals 0. And now we have a nice, easily factorable, there's 4 terms, so we factor by grouping. So we take out 2x squared, hopefully this will work, out of here, which is x minus 4, and then we take out plus 10. Oh yes, and they're the same, so we take out the x minus 4. So the only answer here, you can't factor this any further. You could take out a 2, but it actually isn't going to help at all. So you would set each equal to 0. This is going to have no real solutions right here. I can tell already, because I would get a negative under the radical when I try to solve that, so that's out. So the only answer that makes sense is 4. So the outer dimensions, to answer the question, the outer dimensions are, we use the numbers in the picture, 2x, x, and x. So it would be 8 by 4 by 4. 8 by 4 by 4 feet. Ta-da! So you can watch this again later.